In this video, we'll solve SBQ2. So the first question is about torque. It's giving you force. Axis of rotation is labeled. The distance from the axis is given. The angle is given. The formula which we'll use is RF sine theta because there is an angle given. Substitute the values which are given in the question and you get the answer for it. 32.14 Newton meter. That's part B. The next question was about moment of inertia or rotational inertia. The formula is sigma mr square. We apply for the three particles m1 r1 square plus m2 r2 square plus m3 r3 square, and then for m1 it is 2ml square, then it is ml by 2 square. You can check in the diagram. M is at a distance of L by 2 and m3 is 3m whose distance is not known. We are taking it as x square. The moment of inertia is given as 23L square by 4. Now in this equation we can see that we have three variables. One is L, one is M and one is X. That means three unknowns, and hence we cannot solve this equation. That means it's an incomplete information. Next one is about equilibrium. It is asking you to find out the equation for translational equilibrium. Translational equilibrium, we know sigma F is equal to 0. So from the diagram you can see that along x-axis there are two forces, FF and P. FF is positive and P is negative, so FF minus P equal to 0 will be the equation. Next is translational equilibrium along y-axis. Same thing we repeat, sigma F equal to 0. You can go back to the diagram and check. Along the y-axis there are two forces, Fn and Fg. So we'll write Fn minus Fg. Fn is positive, it's going up. Fg is negative, it's going down. And we'll get the equation, that is part B. Now the last one, it's asking for rotational equilibrium and it's saying that take O as the axis. And we know that there are two forces passing through the axis, that is Fn and Ff, and therefore they will have no torque. So we are left with two more forces, that is Fg and P. Fg is at a distance of L by 2. The angle is labeled in the diagram. Check for the angle. You can see that Fg is going to make an angle of 90 minus theta. Use geometry. Okay. And clockwise and anti-clockwise we can label in the diagram so that when we write the equation we know which one is positive and which one is negative. So PL sine theta positive minus Fg L by 2 sine 90 minus theta. So our equation becomes the last one. So this is equal to 0. Next question is about again net torque. We had done this kind of question in the class. There are three forces, F1, F2 and F3. Net torque will be tau 1, tau 2 and tau 3. So 20 multiplied by 5 is positive because it's anti-clockwise. Then 30 multiplied, 30 there are two of them, so we are looking at F2. 30 multiplied by 5 multiplied by sine 45, again positive, it's anti-clockwise. And the last one, 30 multiplied by 10, you can look for the distance will be 10, because we can see that the distance, this distance is 5, so the total distance, if you want to find the total distance, that will be 10, which will be same as this 10 centimeter here. So we apply the equation, we substitute the values, we get the answer as 93.9 Newton centimeter. That's negative. And we convert that into meters by dividing by 100 and we get as negative 0.939 Newton meter, which we convert into significant figures, two significant figures. We keep only 2 SF. Okay, the next is rotational acceleration of the disk. The formula will be sigma torque equal to I alpha, where alpha is the rotational acceleration. I you will get from the table, which is half mr square. Okay, substitute the values for m and r. Don't forget to convert r into meters. Get the value for I. And then we substitute into the equation for alpha. Sigma torque is from the previous slide, or previous question, previous part of this question. Substitute the values, you get as negative 47. Do not forget the unit for alpha is radian per second square. Then the next question was very easy. It is again rotational equilibrium. There are two people sitting, 160 kg, the other one you don't know. The distances are given. We'll label clockwise and anti-clockwise. Then we'll make the equation. 60 multiply 9.8 multiply 1.5 positive. Mass of Hamad, which is not known. I'm sorry, this should be mass of Mansoor. So that's the mass of Mansoor. Multiply 9.8 multiply 3, it is negative. We solve for mass of Mansoor and we get the answer as 30 kgs. Then again rotational equilibrium. Same formula you have to apply, but before that in the diagram we will label the distance. 7 kg is at a distance of r, so 2 kg will be at a distance of 6 minus r because total distance is 6. Label clockwise and anti-clockwise, apply the equation. 7 into 9.8 multiply r is positive because it's anti-clockwise. 2 into 9.8 multiply 6 minus r is negative because it's clockwise. Cancelling 9.8, we get an equation. Solve the equation to get the answer for r.